Hello, I'm Luke from Smallfish. It's a bit of a different video today. I'm going to be covering the changes happening in S&box right now. Obviously there's been a lot of changes up to this point, but in my opinion this one's a very confusing one for a lot of people, so I thought to make a video to explain it. The main crux of this change is the entity system removal and the replacement with the scene system. What are these systems and what is the point of them, what do they do, and how are they different and why is it changing? With that, it's going to also change how objects exist in the world. Before, there was entities, and now there are game objects. How are they different, and how do I still kind of create stuff within the 3D world? Because I know how entities work, but how do game objects work? So I'll explain that, I'll explain the difference. Finally, the changes to networking, which is a big one that's confusing people. So I'll cover that as well, but we'll get to it when we get to it. But first, entity versus scene systems. So, what do these systems do? What are they for? The best way of thinking about it is, if you have your 3D game world, and you've got objects in the game world, the system is what deals with spawning them in, keeping track of them, and running all the systems need to actually like render them, to do physics on them, or if it's light, do lighting for it, and so on. Connects them all together in a nice little game loop. So here's a nice example. On the right is a player, and to have that player spawned in, we'll use the system to spawn it in, and the system will keep track of it. It will be rendering the model, it'll be doing physics on it and networking all this stuff. And the system's going to say, okay, so for every object within this world, every player, every prop and so on, we're going to do physics on it 60 times a second, so they're all doing physics at the same time. We're also going to render them all this many times a second. It basically loops all these little systems together and have them running in a nice game loop, and while it's also keeping track of every object within that world. So, the way the entity system does it, you'll see instantly there's a server DLL and the client DLL. From now on I would say server and client because it's easy. So with the entity system you'll immediately see that it's multiplayer. There's a server side and a client side. The server is what the clients connect to, and the client is a player's game. So it's always running in a multiplayer type of way. And the systems inside, instead of them being the same, there's two different sets of systems. There's the client systems, which is for rendering stuff and loading maps and doing lighting and all this stuff, which technically a server would never need to do. And it also has client networking, which is specific to how it does networking. And then there's a server side, which kind of deals with like physics and information that needs to be sent to the client. And also it has its side of networking. Another thing to mention with these systems, they're specifically built within these DLLs for the game loop. These DLLs are C++, because that will be important later. So here's an example of some entity code I've made. I'm using a few different things from each side. Like I'm rendering a model, and I'm doing networking from the server to the client and so on. So, the grey pieces of code, it's generic code that can be run on anything. Blue pieces of code, I'm accessing a client-only system, like rendering a model. And red pieces of code, I'm doing the same but for the server systems. So what happens when I try and run this code? Both sides are going to error. The server reaches the client code and goes, well, I do not have the client systems available to do that, so I cannot run it. And the client does the same but with server side systems. So, when you're making your code, you're having to split up server only systems, client only systems that you're using in the code, into separate pieces of code that are run differently for the server and the client. The way Gmod dealt with this was you would have a client file for the code, the server file for the code, and a shared piece of code that is for both sides, and it would run them differently. The way S&box dealt with it up to now was you would have an if statement for excluding server code and an if statement for excluding client code, and that way you can have the client run it code, see that there's server only stuff coming up, not run it, and run the client stuff. The server can go for it, go, there's server stuff, I should run that, and see, but this stuff is client, don't run that. So yeah, you're having to split them up so you can run the code without it erroring. Here's a nice little example. I'm doing like a basic player. So on the right is my game that's running, my visual game I see, and it's reusing the client DLL. On the left is the server running the server DLL. And so the server is dealing with physics and dealing with the positions and collisions and everything with my player. it doesn't have anything rendered, it's just like a box that represents the bounds of my player. Now you get the correct value out, and you can network that to the client, or clients, because technically it's always meant to be multiplayer. But this is a single player, so we'll network it to my client version of the game. It receives that, and it's a position, for example, and it goes, well, I can render a model at that position with this scale and rotation, and I can also play a sound from it and an animation and so on. So what it is going on here is the client side deals with all the visual side of stuff, and the server deals with information, so you're always thinking about that split. Another extra thing to mention, all them subsystems I'm on about, they're built specific for the DLLs for the game loop. So you can't easily, let's say, access the rendering system outside of the game loop. So let's say I wanted to render a model in a sandbox tool. You can't easily do that with the client and server DLLs. Yeah, you can kind of fetch it from the DLLs if you need to, but it isn't an easy thing to do. Another thing to mention, the way the entity system loads into games is it always loads into a map and then loads the entities. So you can't, let's say, switch a map in the middle of playing. You have to kind of stop your game loop and then restart it while loading a new map and load the new entities in again. So it's kind of disruptive to gameplay if you wanted to load into multiple different maps. But yeah, there's been a changeover over time, because when they originally got the Source 2, they just used this game loop, this system, just because it was all there and it made sense. Why should we remake every single system here when we've got access to it? But over time they realised how restrictive that is, and that they want to use these subsystems in Sandbox. So they've had to start pulling it out with like C++, the DLLs, and remake it in C# to be accessed in Sandbox, so you can use it in the tools. So many of these subsystems have been pulled out though, that they're at a point where the DLLs are fetching them back out of Sandbox to run the game loop. And to be honest, they don't like how the game loop works too much, because other modern day engines don't work this way. They don't have a server and client specific. Everything exists within one game, and that's run for the server, the players hosting, they all run one thing. We're wrapping these systems that are now in Sandbox into our own game loop, which is a scene game loop. And there's no separate server, client, everything runs it, everything can network and so on. So, let's say I've got a piece of code made for the scene system, where you'll notice it's all grey. That's because it all works in the scene, no matter if it's a dedicated server or a player hosting or a player. So if we run it, it's always going to work, since everything we need is already there no matter what. Dedicated servers are a bit of an exception, because they shouldn't be trying to render models and such, because they're a server. It would be a waste of processing power to do that. But that's just a minor thing. Every other instance, you want access to the systems, it's easy. This is the way I like to imagine a scene system, is you've got your scene game, which is wrapping them systems from Sandbox into a game loop. But then you also got the scene tools, which are the same systems wrapped into a tool. And the tool is quite static, it isn't running stuff like every frame, it's just there in a static world, and it allows you to build up a scene with game objects and components, and you can view it in your editor. You can view changes real time. Save that scene, and then the scene game loads the scene, and it looks exactly like it did in the scene tools because they're using the same systems. So that's the way I like to imagine it. So, a quick TLDR if I've over-explained it or it isn't clear enough. The entity system is running two instances of the game. These two instances have different systems that run the code differently. So, when making code for it, you have to split it apart. The two systems have systems inside that are only built for the game loop. So if you want to use these subsystems like rendering outside of the game loop, it isn't easy to do so. So making tools for development isn't really easy to do, and it's hard to play test, but it's hard to make changes because you have to continually play test, you can't view it at all. The scene system, all the systems it uses for the game loop is in Sandbox, and it can be used in other tools, which is a nice bonus. But we've wrapped all them into a nice game loop, and we can actually view what we need to within the tools. We don't have to continually keep booting up the game just to view stuff. And also to mention, there's no split between server and client with that. It's one thing, it's just a scene game that runs no matter if it's a server or a player. Now, how do objects exist within these systems? So you've got entities for the entity system. and you've got game objects for the scene system. The way entities work is you have fully packaged up entities with all the functionality it needs. So a player will have its player controller, its model, its animator, its physics, an inventory, let's say if it has an inventory, that all packaged up, ready to go. So when you spawn that entity in the entity system, it's all there ready. And obviously the code within that entity is going to be split between the server and client. Game objects on the other hand, I like to say they're a step behind entities, like they aren't an actual pre-packaged up thing, they are just a point in the world that exists. We can turn it into something else by attaching components with the functionality. And there's no server client split on them components, it's just a component with its code that will run the same on the host, the player or the server. Here's a nice example I like to have to visualize it. So on the left is our entity, everything's ready to go. I can't easily turn it into something else, like it's a player entity. I can't, let's say, turn it into an NPC because it is what it is. I'll have to delete it and spawn in an NPC entity in its place. With game object, well, I can easily change what it is at runtime. So I can add components like a bunch of model, physics, inventory, player controller, animator. I can add all these components. It's a player now, but I can remove the player specific components and replace them with NPC components. And now it's an NPC, it doesn't matter, it can be anything I want. And that's like the dynamicness of game objects. On the code side of things, a nice way of thinking about the change is obviously on the left, all these things going on within the player is all within the entity, all one big file. The main way of shifting over to the game objects is you're thinking about them individual things going on and splitting them out into components. So like an inventory component rather than like inventory in the player. A controller component rather than a controller for the player. Animator component rather than an animator for the player, and so on. Another thing you might mention though is, well, what happens if I want my animator to play an animation when the controller does something? Well, in that case you just create a reference. In my controller component, I want a reference to the animator component. If there is a reference, then I just play a jump animation on the animator when I have a jump input, and that's just all you need to do. This is something I've already mentioned, but I'm going to mention it again. The entities, you can only preview in a game. You cannot like preview in a tool or anything, you have to play test in order to see changes. You change the scale and rotation of your entity, you have to play test it and view that change. Game objects though, because it's a scene system, you can view it in the tool real time, so I change my rotation and scale, and I can view in the tool. It's there, instantly like that. I don't have to go through like minutes and minutes of loading up the game and testing that way. Obviously when I play it in game, it's going to look the exact same since the tools in the game are using the exact same systems in a very similar way. But ideally, maybe there's some scenarios it doesn't, but for the most part it will. A few extra things with game objects that people might want to know or I should mention. Obviously you'll be thinking, well, it's really stupid that I can't create a pre-packaged entity like before. Like, I want to spawn in a player entity as one whole thing and not have to preset it up. Like, I don't want to have to create code to spawn a game object and set up all the components to be a player. You don't have to do that. You can just create a player prefab. The player prefab is basically the game object of all the components set up to turn that game object into a player. And that's saved into a file, and you can load that and spawn that in when you need to. Basically create an instance of it, a copy, and assign it to a player. And so prefabs work like the pre-made entities, and game objects aren't entities, they're just points in the world. And another thing to mention, the entity system, obviously it loaded maps in as its like base. The scene system loads scenes, but I can put a map into my scene as a game object with a map component. And what that means is I could switch a map while the game's still running, because it doesn't rely on the map to be its like backbone, it's the scene that's the backbone. So I can, let's say, load office and then go, actually I want the players still to be able to run around, but I'm going to switch it over to flat grass now, and you can do that, which is really cool. I'm not sure if we can spawn multiple maps in, I think it's only one at a time at the moment, but who knows the future. Actually, also, this new system is basically Unity if you want to look into it more, but that's the general idea. Now, networking. What is networking before I get into it? Let's say I'm playing a game and my friend's also playing the same game. I move player 02 backwards. how do I have my friend's game have his player 2 move backwards to the same place? And that's networking. It basically syncs up things like positions, rotations, values between multiple games across a network. And obviously the biggest network in the world is the internet. So yeah. So with the old networking, if you listened to me earlier, I did mention the server and the client split. They both have different sides to how their networking works. The server, how it does it, is there's one server. The client, there's multiple clients connecting to one server. The server networks out, change the values to every single client at the same time. All the clients receive it. And that's the general idea. It's a one-way system from server to all the clients. There's no back and forth, it's just one way. It's very simple to think about it that way, but it's very restrictive at the same time. So here's an example. All these players exist on the server and it's owned by the server. Below them is a client that wants to control it. So let's say the white player wants to move forwards. It cannot just move its position forwards. It doesn't have the ability to do that. What it has to do is tell the server, I've sent a forwards input for a few seconds. The server will receive that and go, okay, if you walked forwards for a few seconds, your position would be about here now, and it would move it forwards by X amount. Let's say you walked forwards 2 meters per second, and you walk forwards for 2 seconds, you've moved 4 meters forwards, boom, there you are. Everyone that's connected, the position of that player is now here, and it networks it to everyone. It basically has control over everything. And with that, it's a server authority networking model. With the new networking, obviously there's no server client side of things. The server, the player host, the players are all running the scene game the exact same way. So they all have networking the exact same way. So in order to send and receive values, everyone needs to have the ability to send and receive networked values. So that's what they've done. Obviously, when I say this, you'll think, well, let's say everyone's changing a networked value, the same networked value. Who's going to have the final say of it? Who's going to have the authority of it being correct and networking it to the others? That's one thing they've had to do. You can assign ownership, networking-wise, over game objects to specific connections. So at the bottom is multiple connections, be that a player host, a server. They're all the same. And above it are game objects. Obviously you'll see the white connection has a white game object above it. And that's because it owns it. So it can say, I want to move the position here. So it figures out a position and it networks it to everyone. Well, everyone will go, okay, the white connection has moved the white game objects forwards. Well, it owns it, so we'll accept that value. But what it cannot do is the white connection cannot say, well, I want to move the green game object here. Everyone will receive that and go, well, you do not own the green game object. The green connection does, so we're going to ignore that. And so it would have to be reset on the white connections game. And that's a general idea. Basically, everyone owns networking over a game object, or doesn't own networking over a game object. And that's how you deal with who is in charge of what. Another thing to mention with this new networking, before a lot of the things were hidden behind the scenes, but now we have access to like seeing individual connections and how they connect to each other, and you can assign hosts and dealing with network messages, and you have a lot more control over it basically. So what that means is we can create our own networking models. Here's a few examples that we'll get into. So here's a possible model number 1. This is currently what the scene system uses as of testing. So every player is connected to each other in a player-to-player or peer-to-peer sort of style. But there's one person there in that connection pool that's assigned the host. And the host doesn't mean anything other than the fact that objects are networked but unowned. The host simulates and networks them. It doesn't own them, but someone needs to simulate them and network them, because otherwise it's going to be frozen in place and not have physics and stuff. What we can do here now though, is because everyone's connected to each other, well, if I leave or I crash, me being the host, we just assign a new host to a different player. And now they basically take charge of simulating and networking unowned objects. And that's just what's going on with the new networking model. We can do that. Or let's say I want to make my own networking model. I kind of liked how server and client worked before. I liked the idea of that one thing owned authority over everything, and everyone had to ask that for changes. But I also like the fact that when someone crashes, the host, you can switch it over to a different player. So I'm going to make my own system like that, my own model like that. So here I'm just going to say the host owns ownership networking wise over everything. In even unowned objects it simulates and networks them. But on my game objects I can assign, let's say, a connection to control it. It doesn't own it, it just controls it. If client or a connection sends a networked message to me saying I want to move this object forward, so I walked forward for a few seconds, where should I be? If it has control over that object, technically, I can receive that and go, okay, so you should be about here. Figure out the position and network it to everyone. It works like before, but a little bit different. But let's say I crash. Well, now I can switch the host to someone else, like before, like with the peer-to-peer. But it still kind of works like the server-client kind of model. I can create that model if I wanted to. It's pretty easy to do so with the new system. So that's basically how networking works now. It's a combination of being able to send and receive networked messages between the server, the player host, the players, any of them, because they all run the same, and also setting up your own network models. You might be scared though, saying, well, I don't want to touch with networking model, I don't want to make it myself, I'd rather just use whatever the base networking model is. Well, the plan that Facepunch have said is you'll have a few default preset networking models to choose from, like the peer-to-peer one we've seen before, which is really fun and easy to work with, but can be a bit vulnerable for like competitive games and hacking. Or you can have like a server authoritative sort of network model like before, and yeah, so it'll have a few presets to choose from, one like before, one like the current one, maybe some others. So hopefully that's cleared up a lot of what's going on with the changes. One thing I'll also mention, stuff's changing actively a lot right now, but once the scene system's more solidly in place, please keep your eye out for a future series coming out with Smallfish, because I'm pretty sure Ubri plans to remake the Yeti Escape tutorial series, where he makes a Yeti Escape game with the entity system, but this time he'll use it with the scene system, so you'll get to see how do I use the scene system, how do I create components in the scene system, how do I create UI in the scene system, how do I set up a scene, and how do I create prefabs and all this stuff. He'll explain it all to you in like a series of videos. Hopefully that will give you a very good easy first start to getting into the scene system. But now you should hopefully understand the basic concepts of all the changes and why they're different, and it should be a lot less confusing and scary, and there's a lot less questions going on, ideally, if you've watched this. But have a good one!